Bismillahirrahmanirrahim. Assalamu alaikum. My name is Mohammed Asim. I'm working as DevOps engineer. Guys, in this video, we are going to see what are Kubernetes affinities. So let's begin. So what you need to do, of course, with the start of the deploying this all stuff, you need to have Kubernetes cluster. So I'm using EKS in this demo, right? And we have two machines, on demand and spot. So what I've done, I've spun up through Terraform, and let me show you the stuff with regard to the Terraform. So I've added two labels, right, for on-demand and spot, right? So if you navigate to the module section, navigate to the EKS, and in the main.tf, I just want to show you the labels. So okay, so for lifecycle spot, this is the label, and I just want to show you from here as well. So right, and these are the labels which we have set up through the Terraform, and simply also check the labels. So I'm going to copy this guy, show labels grep lifecycle. So simply do that. You will see the labels regard to the lifecycle. You see, this is the lifecycle EC2 spot, and two nodes with EC2 spot, one node with EC2 on demand. So these are the labels. So let's begin. And if I do ls here, right? So if you navigate to the section affinity, we are going to take the example of this node selector. So this is pretty much simple. It is going to simply use this selector lifecycle and EC2 on demand, and it is going to spin up, for instance, two replicas. So simply do kubectl apply -f, right, and simply do the node selector YAML. So I've also imported this cluster in Lens. So if you see two pods has been spin up, and these are the same nodes. So, and also you can do from the CLI kubectl get pods -wide. So let's do that, and you will see the DNS name regarding to that those particular port launch on the same node. So simply do delete kubectl delete -f 0, and then we are going to see the soft and hard limits regarding the node selector. So simply close this guy, and if I navigate to this section, so we are going to do the deployment, and hard mean that the pod will not schedule if the node does not have the label. For instance, let's say we are going to deploy 38 pods, right? And those particular nodes, like for instance, we have two EC2 nodes, and with the hard limit, let's see what happened. kubectl apply -f. So sorry, to this guy, no definitely hard limit. So you will see shortly that pods are going to be spin up, and shortly we will see some of the running pods, and some of the pods are going to be stuck in pending state. You see. So why it's happening, you can simply do the describe pod as well. So also from the Lens UI, you can do that, but definitely you will see some of the pods are going to be stuck in pending state because we have set up the hard limit, which means that if those don't have enough capacity, the other pods are going to be stuck in pending state because we have set up the label selector EC2 spot. Although we have one node available with on demand, but it's not going to provision the pod, and the pod is going to be stuck in pending state. So let me do kubectl get pods -wide. So from the CLI, definitely you can check the what's happening, and also, for instance, this pod. Take the example of this pod kubectl describe pod name of the pod. Always do I do namespace, although it is in default namespace, but you will have better practice to do this giving namespace. So in bottom, you will see the event type, and you will see this is from the default scheduler, and it is complaining that the other nodes have don't match the selector, so cannot schedule on that. So simply from the UI, you can see the issues as well. So scroll it down, scroll it down. So you see same stuff from the UI you can get as well. So anyway, let's try to do similar stuff with the soft limit. So simply what I'm going to do, I'm going to simply do delete, and we are going to apply the soft limit. So simply navigate to the section to affinity soft limit. So what is the soft limit? And soft means the scheduler will try to avoid placing pod on a node that doesn't match the selector, but it is not required. If the scheduler can't find a node without the selector, then it will place the pod on a node that does have the selector, right? So it simply means that if because our limit we have set up or our requirement is soft, so soft means soft. So if uh, the scheduler is unable to find that selector, or like for instance, we don't have much nodes, what it's going to do is going to launch the pod anyway on other nodes. So we have the wait section here as well. So let me show you the wait. Sorry, this one, right? So wait means that scheduler will try to avoid placing a pod on a node that does not match the selector, right? But it is not required. If the scheduler can't find a node without the selector, then it will place the pod on a node does that does not have the selector. So right, so selector is this one life cycle, EC2 spot. So with the same 38 pods we have deployed from the hard limit, let's see what happens if we go for the soft limit. So kubectl apply, uh, do apply the soft limit, right? So you will see the pod in pod deployment, and let's see what happens. So some of the pods are stuck in pending state. What's the user looking for? That hey, we don't have that particular selector, but anyway, the limit is soft. Let me try to deploy all the pods. So this is what happens if you use the hard and soft limit. So go for the soft limit in case. I mean, otherwise your pods are going to be stuck in pending state, right? So I mean, if you don't have the capacity, simply do that. Simply do. Delete the pods. Then we are going to take the example of, um, let me navigate to the section, affinity, third pod, pod anti-affinity. So what it does, it is going to spin up three pods in a highly available way. For instance, we have pod anti-affinity defined. What it is going to do, your application is going to be highly available. So simply if you okay, kubectl get nodes. So let me do kubectl get nodes -y. So your nodes are actually highly available in a way that it has been deployed on different ages. You cannot see from here, but if you navigate to the section here and right, so if you see the description regarding those, so let me scroll in a bit. So you will see the ages in which your actually nodes are deployed, right? So you see this one. So this is a private subnet, uh, US East 1C, right? And click this guy. And this is the private subnet US 1B, right? So we have two spot machine highly available deployed in different ages, right? So if the pods are going to spin up on in a way that is going to be highly available because each pod is going to be launched on those particular machines. So simply click this guy and let me scroll a bit. So it is 1C, right? So click this guy. This is 1A, right? And just wanna make sure one more time. We have one C, we have one A, and scroll it down, one B. So we have A, B, C, right, completed. So now let's try to take the example of port anti-affinity. So kubectl apply -f and simply do the deployment of these pods, right? So our pod should be deployed in a way that it should be deployed on a single node. kubectl get pods -o wide, right? And you will see three pods are going to be spin up, and these are the DNS names, right? So we have just seen that these are the highly available pods because of the pod anti-affinity. So if you're looking for your application to be highly available, you should go for the pod anti-affinity. So let's delete this guy and delete this one. Okay, in the last we'll say pod affinity, right? And let me do delete. Okay, this one, right? Because we have not applied this third one we applied. So delete this guy. And the last one we have pod affinity. For instance, if you want your application or you're looking for very tight, low latency sort of application and you don't want to go multi-AZ, so there might be a scenario where you want to do that. So then you want your EC to be, I mean, then you want your pods to be deployed in a closed, tight networking. So if your pods are going to deploy on the same node, the communication with low latency is going to be available. So simply in the last example, we will see this pod affinity, right? So this is the example regarding the pod affinity, and let's try to simply deploy those machine. We are going to use two replicas, so these pods should be deployed on the same machine. So do kubectl apply -f and simply apply this guy. So what it does, if you navigate to this section and I want to show you, if you check the node, this one and this one, you see the same node on deployed on the same node from the CLI. I want to show you kubectl get pods -o wide. So you will see the DNS name regarding those nodes are the same. So that is it, guys. If you like the video, please like, share, and subscribe the channel. Have a nice day.